Oh, sorry. Okay. I wasn't able to get the video working, so maybe I'll do that at a different time. I promised you that there'd be a Doppler problem on the exam, so I thought it'd be worthwhile to do one more Doppler problem. And it's kind of a tough one, so let's do it. Okay, a police car with a 300 hertz siren is moving toward a warehouse at 30 meters per second, intending to crash through the door. What frequency does the driver of the police car hear reflected from the warehouse? And there's a hint. How many Doppler shifts occur according to the driver? So that's the key. All right, so you have a moving source, and then those moving sound waves hit the warehouse, the wall of the warehouse, and then they're going to be reflected. So the first part, you can basically think of the moving source as the police car, and what does the warehouse act like? Like an observer, right? Like an observer. Okay. So then the sound wave gets reflected away from the warehouse, and then what do you have? And then the sound wave is moving toward the moving police car. So the second Doppler shift is at the car, where the driver of the car is the observer. All right, so let's do that. So number one, so the first Doppler shift. First Doppler shift occurs at the wall of the warehouse, and we're saying that the wall is the observer. All right, so we have a moving source, right? We have a moving police car and a stationary observer. So which equation are we going to use for that? Source approaching a stationary observer, right there. So F plus equals F0, 1 minus Vs over V. So F0 is 300 hertz. And then we have the speed of the car is 30 meters per second. Speed of sound is 343 meters per second. You work that out, you get, and it's going to be larger than 300, right? Because this is less than 1. And we expect it. The car is approaching the observer, so the frequency goes up. So that's going to be 329 hertz. Great. Now the second Doppler shift, occurs at the car. And the driver is the observer. In other words, the sound has been reflected from the wall, so it's moving towards the car, right? It's a stationary source. The wall is stationary. The car is approaching that wall. Okay, so what are we going to do for that one? So now we're having a stationary source and a moving observer. So observer approaching a stationary source. So this one. So again, it's going to be, increase F plus. So we have F plus equals 1 plus V0 over V times F0. Okay, so again, 1 plus 30 meters per second. That's sound, 343 meters per second. Here's the thing you're going to be careful of. What's F0? What's the frequency of the sound coming away from that wall? Is it 300 or is it 329? It's 329, right? It's 329. So you can multiply this by 329. And you do that, and you get, that's an equal sign. You get 358 hertz. Okay, so make sure you understand that, because you're going to have a Doppler problem on the exam. Let's review. Oh yeah, sorry. That was the first one, that was the second one. Okay, so what did we do? So this chapter was about traveling waves. Next chapter we're going to talk about something called a standing wave, which is not a traveling wave, but it's actually made from traveling waves. But anyway, so this chapter, traveling waves. So we used the wave model, and we understood how it differs from the particle model, right? Particles and waves are completely different. I mean, a particle is localized, has mass, right? And you can't have two particles going through each other at the same time. Waves are spread out. It's a disturbance, doesn't have mass. Waves can go through each other. Then we hopefully visualized wave motion. We developed some intuition about waves. We saw that a wave is a function of two variables, position and time. We dealt with that. Then we talked about properties of sine waves, wavelength, wave number, phase, frequency. You have to know what these things are. You have to know that the wave number is 2 pi over lambda. You have to know these things because we're going to use them a lot next chapter especially. Then we did some kind of off-the-wall things, right? We studied important characteristics of sound waves and light waves, and we talked about the Doppler effect. So that's it. Thank you very much. Okay, now